Hi there. So let's continue to learn about Kubernetes. In this tutorial, we will learn to create a deployment. So a deployment, here we see that is responsible for creating and updating instances of your application. Here we have more detail, but I would like to go to the diagram. So here, one important information: application needs to be packaged in one of the supported container formats in order to be deployed in Kubernetes, on Kubernetes. Sorry. So what is all about? We have Kubernetes cluster, and we have nodes, we have control plane. And here we can see that deployment it's stored in control plane in etcd key value store. When the deployment is created, it schedules the creation of the pods in the nodes. It can be any of the node which is most suitable. By default, Kubernetes will automatically choose which node it will be scheduled on. And in case if for some reason that node it goes offline, it's not healthy, that pod will be scheduled on different node which is healthy. So this is cool because it's it's doing the self-healing mechanism, which it means if your app is going down for some reasons, like, you know, some node has problems with its hardware or software, the Kubernetes, it makes sure that your application is still up and running on different workload, and your users won't be impacted, and that's great, and it's automatically managed. And about this statement, in order for application to be able to run in the pods, they should be containerized. And here the kubelet has different runtimes like containerd or Siri.io, container runtimes. So the applications should be packaged. Usually we use Docker, so we are creating Docker containers. We are tagging the images, building them, and pushing to the registry. So this is one of format which is compatible with the current Docker runtime. But it can be different one, like Podman and other. So here we have flexibility. Yeah, and the next steps, she's just telling about kubectl CLI, which we have already seen. And here we have a command to run. So I will split and I will try to run. So we have kubectl create deployment, Kubernetes. This is the name of deployment, Kubernetes bootcamp. This is the image. And here is the registry. This is the name of the image. And here is the tag. So we are hitting enter and it works. If you need to learn more how kubectl works, you can do like create and -- help, and you will get like a lot of information. And even here you can see the usage example, which is very helpful. Okay, so we can see that the deployment has been created. Get deployments. We have the deployment running. Clear the terminal. So we can read what is going on here. They performed a few things. The Kubernetes what did? Search for a suitable node where an instance of the application could be run. So yeah, in this example we have more instances of nodes, but in the Kubernetes we have only one, so not big choice. Scheduled the application to run on that node, and then configure the cluster to reschedule the instance of a new node when needed. So in case the node is not healthy, the rescheduling will be on different node which is suitable for that. So yeah, we can make sure again that it's running. Okay, so view the app. Pods that are running inside Kubernetes are running on a private isolated network. By default, they are visible from other pods and services within the same Kubernetes cluster, but not outside that network. When we use kubectl, we are interacting through an API endpoint to communicate with our application. So in other words, at the moment, we cannot access publicly this pod application. So to do so, we need to do additional actions. So we will cover our options, blah, blah, blah. Okay, here we have one solution. The kubeproxy command creates a proxy that will forward communications into the cluster-wide private network. Then the proxy can be terminated by pressing Ctrl+C. La la la. Okay, let's try. Okay, proxy. So we have started a proxy. When we have a connection between our host in the terminal and the Kubernetes cluster. So in the current example, I have the Kubernetes running on the machine, but if I would have the Kubernetes in the cloud, the kubeproxy will create this basically a tunnel for my machine to be able to access the pod which is running in the cluster and is in the private network. So here we can use this one, this command. So, okay, I can use this one. So let's curl a localhost 8001 version. So here we can see that we are, okay, started the server. This is the localhost running of the proxy, and we hit the Kubernetes. We have the major version, minor, emulated, Git version, and other parts. At the platform, it's ARM. Even we have Go, a little bit old version. Yep, that works. And now we have the API server will automatically create an endpoint for each pod based on the pod name. That is also accessible through proxy. So we need to get the pod name and we will store it in the environment variable. Here we have an interesting command, export pod name. This we are basically creating an environmental variable, and we can get the value of it by running a like nested command inside the braces, the parentheses, sorry, and dollar sign. So we try to query kubectl get pods output in Go template format, and here we are giving some specific template which we want to go over, and this is like Golang syntax, template Golang syntax, like high level. So we range just a looping over items, and this is a loop till the end, and we try to get the metadata name. So let's get it, and let's echo name. So this is the name of the pod. Okay, get pods. Yeah, yep. So you can access the pod via proxy API. So now we can access it via API without curl, kubectl, sorry. So using curl, we localhost API version 1 namespace is default because we haven't specified the namespace when we are creating the we have created the deployment, so it's in the default. Resource pods, here is the name of the pod, port 8080, since we have specified, no, here we haven't. Okay, so hello bootcamp, Kubernetes bootcamp running on Kubernetes. So to sum up, let's go over it. We have nodes, we have control plane. When the the deployment is stored in etcd store, key value store, which has access control plane on it. The pods are running on the nodes and they can be switched from one node to another depending of how that node state is, if it's healthy, if it's working, if it has enough resources. Sometimes some resource, if in case of resource constraints, some pods can be evicted, like eliminated from this node and rescheduled to different one based on the priority. So there are a lot of things, cool things that can be done here. Regarding the deployment, yeah, we create a deployment and Kubernetes takes care that the application is running. And we can use proxy. We can use proxy to access the resources, the container that runs in the pod, because by default the containers run, the pods are running in private network on the Kubernetes cluster. So yeah, that's cool. Thank you. Have to go.